Good afternoon, everyone. Thanks for joining us today for the webinar that we have put on for you. Digitize your factory through no-code tool integrations and data traceability. My name is Shayna Watson. I'm on the marketing team here at PICO. And Steve Wishaw is our head of product, and he will be walking you through the webinar, and he'll be available to answer any questions you have towards the end of the webinar. We do have Q&A enabled, so if you have any questions, please feel free to just pop them down there into the Q&A, and we'll be sure to answer all your questions at the end. So we will go ahead and get started, and I will hand it over to Steve. There you go, Steve.
Thanks, Shayna. Appreciate it. So as Shayna mentioned, I am the head of product at PICO. My background is a retired aerospace engineer that went straight into manufacturing operations. So my product title is making sure that all of the folks that are in the shoes I used to be in, leading a factory, have the ability to manage their facility and document, control, and manage as needed. So to really kind of talk through why folks should digitize and why things are important here, 72%, almost 3/4 of manufacturing operations are still performed by humans. This is less than, automation is less than 0.5% of all manufacturing in the US. Yes, there's big facilities. We talk about the blue chip manufacturing companies that we all talk about in managing stock market expectations and what really drives the GDP. Those folks make a lot of noise with their large facilities, which is great, and they need to based on their volume. But that image on the right is much more common. We've got the work instructions, we've got a printer, we've got a torque tool, and somebody just doing what they need to do to stay safe, to go home and put a hard day's work in. And this is just a guy torquing bolts with a screen in the background, but he's probably been doing this for a while. And we want to augment this guy. And because human beings are still in charge of these assembly lines. These are assembly lines that are moving. These are bench builds that need to feed other customers or suppliers, and these methods need to continue as a way to continue supporting these folks. Because when humans are involved, mistakes are inevitable. That ideal data entry clerk can only be so good 97, 98% of the time. And that only spirals down when we're talking about our true artisans out in the manufacturing floor. Digitizing enables that error proofing on the shop floor because, again, data entry is hard. And that paper-based worker guidance, those of you that are in the facilities that have a binder up on the shelf that might have a little dust on it, not sure what revision it is. Does this actually accommodate and control all of the recent changes that our customers are requesting? We have all sorts of different noise points that folks can deal with on the manufacturing floor. And even when people are trying to be perfect, there's all sorts of these distracting factors that are taking away. So when we talk about a digital factory, how do we manage, these expectations that we have coming in? And what are the benefits that are really supporting the granularity of what we're supposed to be doing? So the benefits that we've seen across our customer base and folks that are along their Industry 4.0 journey include those real-time analytics to help you make decisions faster. Nobody likes firefighting. It's an age-old tradition, but those real-time analytics help you make decisions quickly, the day they're happening, the moment they're happening, instead of the next day, week after. Those tool and equipment usage analytics can help determine that service life. Are we getting that active feedback from the equipment that we're using? And what is that, accurate cycle time data? What does my production look like? What are those things that I actually need to do for continuous improvement? Am I experiencing operator inefficiencies because things aren't clear, or I need more training? Are my stations not actually running? Do I have some hidden downtime or rework that's not being accounted for? All these types of things can start to be captured as we start talking about a connected factory along the way. So what are the steps to get started in digitizing my factory? When we look across our customer base, we've got a few different things we need to account for. One of which is the tool and device integrations. The platforms, think SCADA, think PLC-driven factory systems of, I need a controls engineer to put all these things together. What we want to enable is a no-code hardware integration of commercially available tools. What that means is I have some device, torque tool, a printer, a scanner, some high pot electrical tester. All of these things communicate via industry standard protocol, why do we need to repeat work every time we integrate one of these things or plug it into the shop floor? So we want to make sure we have that integrated library of things available to plug in whenever they're on an accessible line network. How do I capture information directly from those tools? To support that, we want to make sure that we can actually track those parts that are moving down the assembly line. Where's all my work in progress? What have I finished today? What's that build data relevant to a process, a station, an operator? Am I within control of what I'm trying to do? And we want to make sure that we can see those things again real time in dashboards or other reporting mechanisms so we can see those issues and see those efficiencies as they come up. So to really kind of dive into a couple examples of that, here's a kind of quick agenda of what we'll be covering from a demo perspective as we walk through what's possible in starting this digital journey. The first thing we're going to do is serialize some parts for traceability by taking in a label printer. How do we get away from writing things down on a traveler? How do we make sure that those touch times are beneficial and that visual management is beneficial so we don't just go from trying to read a piece of paper, did the paperwork get lost from the part, or putting a literal sticky note on the part? How can we transact and make things more approachable from our operators? The second is we're going to add a torque tool and connect it to our process to make sure we're building and documenting our fastening processes completely. And then we'll take whatever we're working on, that process serial number, that product identifier, we're going to trace through the history of our line and make sure that we can capture that from that scanned barcode along. So before I dive into the demo, I just want to highlight a couple overview items for PICO that are really important to the fundamentals we're talking. The PICO architecture is designed to mirror that real life factory and layer in that error proofing on top of it. So this is going to be very similar to the physical setup of your station. We need that workbench, that station, that assembly line area, that is that digital representation of what's happening. This is where a lot of those tools are going to live or that work is being performed. The second required piece is that process. It's the sequence of steps or operations that must be followed to complete a build. That's where we're going to build in those quality checks, those actions, those fastening, those scanning mechanisms, and other things to complete that build as we need to. The third piece, of course, is that operator or that person that's doing the work. Fairly self-explanatory, but we always need some record of who's performing the work. And what we're about to dive into is what we call a device or a tool or a piece of equipment, but in PICO language, it's a device that really ties through all of these things. We have a device that is assigned to a station, which means that this device is available to be built using any of those processes available at that station. That device is capable of performing actions on that process. So if I'm scanning something on my process, a scan action, it only makes sense that I'm expecting a device, a scanner, to be able to perform that work. Same concept for torque tools and printing labels out. And of course, folks need to be able to use those tools assigned to those stations. So I'm going to switch over to my demo here. And as a quick overview of what we're expecting to see in PICO here, we're going to walk through a quick example of a bicycle. We're going to be installing a seat post, calibrating some brake pads, and doing a little quick QA on it, but we're going to be configuring our process to enable our operator to be successful. So we mentioned that first thing we wanted to do is add on a label coming from a label printer to capture that serialized information. So how we do that, if we manage through that through our devices, we have a full section dedicated to our devices. You can see some on the screen here as well. But we have a fully set up device library to enable these devices to be added. I mentioned those pre-existing integrations to be able to add and manage the content that we have available to us. When we talk about managing those devices, we have this library of items available, and we have all sorts of categories listed to be able to manage the different sections or the different categories of tools available. In this case, I'm going to be honing in specifically on my label printers here, which is going to navigate me down to my section where I have all my different options and brands available. These can range from different models. In this case, I'm going to use my tried and true 4-inch desktop printer here. When I click on this printer, it's going to have some overview information for me. For those interested, I also have the links to the manufacturing site, a link to go purchase more from as needed. through our network of partners, distributors. This is all direct through the hardware providers. When I engage and start configuring this printer, there's a very limited number of things I need to do. And it's all listed on this modal that we have in front of us here. This is going to be my bike label printer, for example. The only mechanisms I need to do is assign where does this thing live on my factory floor. Is it an edge device or an Ethernet based device? In this case, I'm just plugging it into a USB port directly on that device communicating with our server. And then we want to know what station, as I mentioned that architecture before, which station is this printer going to be doing some level of work. In this case, I'm going to be doing it at my bicycle assembly station. And then if there's a serial number that I want to add on here for asset management or other things, I can certainly do so, but that's optional. So when I go to my pages to be able to add in that configuration and how do I manage that workflow, when I go into my QA process here, I have a process already set up here where I'm going to do a couple things and I'll just walk through the process that it exists. I'm going to scan in that bike serial number that I'm working on. I'm going to do some QA. I'm going to confirm some quality, pass, fails, and other mechanisms, but I'm actually going to add a new step in here that is printing the label. And all we have to do to configure that action is go into our action configuration menu directly from that step expected to do that action. When I select that specific action, I have a menu of choices here, whether I'm scanning something, taking a photo, torquing something down, printing out that label. All I need to do is hit that label and I can continue configuring. And this will allow us to start managing some of our templates within that action. So in here, again, we're printing out that bike label. There's a list of templates available within PICO. In this case, I'm going to be using a bicycle label that I already have pre-configured. I won't go too much into the label configuration setup because it's actually quite simple. Coming from either a Zebra printer or an online platform like Labelary, all we need is the essentially output or the code format of that label. In this case, you can see my label here that I have set up that's already been implemented into the system. But all we need to do is have this structure of this template available, and how we manage that. There's a couple different fields. So if I go to my label template here, there's a serial number field and a part number field that I want to be able to dynamically change every time I build. All I need to do for each of these fields is to say, is this something that I've already captured in the build? Is it a serial number I scanned? Is it a static entry that I need to just type in now? In this case, for the serial number, it's something I've previously captured in the build. In this case, I want to record that bike serial number instead of that distance measurement that I'm taking. And then alternatively for our part number, we have some preloaded things in those template. If it's some static text, it's just going to come with that part number directly. That's just part of the template, but I can always change this as needed on a process by process basis or include an action earlier on in my build. All I need to do as my final step is to assign that device as an action, what device is performing that action at the station. In this case, I have that label printer. It's already pre-selected for me. We do some intelligence just to say, yep, this is a print action. I have a label printer at the station. I'm just going to tie those together. If you have multiple stations, you'll want to select the right one. And then to benefit the operator, do I want to have that technician press a button and say, go ahead, I'm ready to print now? Or do I want this to print out automatically when that build happens? And just to benefit and not having any screen time interactions, I'm going to go ahead and hit automatic after step begins. And that's it. Now when I get to my build, I have a action ready to go. So as I'm going through my builds here, I have the ability to track through and manage things. Shannon, do you have a question? I see your hands up.
Yes, had a couple of questions come in. First question is, can I use labels I already have and print those out using the PICO integrations?
Yeah, great question. So this label I have here is something that already exists in my factory today. So all of those can come from a Zebra software that can be configured on a platform like this. Those are just copying and pasting into our platform, and we're just substituting in and out fields. We actually prefer that you have your own labels because you're coming in with some purpose of this is what I'm trying to accomplish. But we also have some templates available of I'm just trying to manage some sub-assemblies or work in progress. How do I manage these parts that aren't quite done, but I want to have a serial number or some traceability associated with it? But we love having these pre-existing labels as part of the system.
Okay, great. We had another question. Do you want to answer another question or do you
Yeah,
want to get that?
absolutely.
Okay. Okay, Tim is asking, can I manage print templates in Pico?
Absolutely. So we have a place within PICO that manages all these templates directly. It's part of our system configuration menu. We have the ability to have these as part of our system to sit within that system configuration. All of those templates can be named. We can manage our fields appropriately as well. So each of those templates has its own special home in PICO and can be recalled by any process when you're building out your work instructions here.
Great, thank you. One more question from Sarah. Can I use any torque tool brand with Pico or is it limited to specific brands?
Yeah, that's a great question, and that'll actually help me segue into my next topic as well. Because now that we've set up that print action, how do we get those torque tool actions set up? So what I'm going to do is go straight into my library here and kind of jump back into the presentation to answer that question with a little demonstration here. So when we talk about torque tools, they work very similarly to the label integration where we can either access them directly or most likely they're going to be living on the network somewhere. So that printer via Ethernet can live on the network somewhere. Alternatively, we have a number of brands tools that live available to be built within the system as needed. So if we're going to be walking through some controller setup, so each typically in the torque tool ecosystem, you're going to have a controller and a tool. The first thing we'll do is build out a example controller where we'll say that this is our assembly controller number 2. If there's a serial number or location on the floor we want to include, those are options here for us. There's only a handful of things that we actually need to specify when we're setting these things up. The rest is handled via the controller, and we just communicate via the industry standard open protocol spec. So what we typically do is have that controller's IP address wherever it is on your factory. Our architecture all lives locally, so there's no latency to and from your factory. We go directly to the tool on your network locally. There's a standard open protocol port that you have the option of changing, but typically speaking, those are all straightforward. And then there's some standard controller language updates needed to either scan for new updates or trace individual rundowns. In this case, those aren't needed. So I'm just going to add in that controller as well. The second thing I'm going to do is come into my library again and then add in the specific type of tool I will be integrating with. There's some options already loaded in the library here. There's a couple different QX pistols from Ingersoll Rand. I just added an Insight controller. I'm going to go down and add in another Ingersoll tool as well. In this case, I think I'm going to go for let's go for one of the right angle tools instead of the pistol grips that I have in there. So this, again, the standard specifications. In this case, I've got a 27 Newton meter target max here. This will be my assembly right angle. The same principles as before. Instead of where does it live on the network, I'm going to pick which controller it lives at. I'm going to assign it to a particular station again. In this case, the bicycle assembly station instead of inspection. And then your standard optional fields for either part number or tool serial number. Very helpful for calibration and asset management again, as needed. So when I create that tool, I'll have the ability to add it into my workflow to support some faceting. So what that looks like, and I'll go back into my bicycle example here. Let's say I'm going to replace an old torque action that's on this step. So to add in that new action, I'm going to go into that similar menu that we had for scanning. In this case, I will be selecting my torque action here. This will allow me to specify what's being fastened, and then the batch count and the configuration ID. So when we talk about what's being torqued, these are just the seat clamp bolts. And then this is asking me essentially how many bolts do I have to fasten here. I've got 4 that I want to accomplish. And then I want to call a specific program from the tool. All these jobs are managed directly on that controller. We're going through open protocol to manage that controller communication. We're just selecting a specific job. In this case, we're going to call program number 2. There's always more information here depending on the specific brand. They might refer to different things, and we've got a call out for that, but we have the ability to manage that. Similar to our printer, we need to assign what is actually performing this work. So we're going to select any given tool to do this. I'm either going to do the right angle tool, an inline, or that pistol. In this case, I want to use the QXX 4 Newton meter pistol that's in that library. And when I manage that, this will create that action for me. If I have this device happening at multiple stations, right now this is being processed at a specific demo station, but if I want to do some work at that bicycle assembly station, but this same process can happen in multiple places. You'll see that I've got new triangles that popped up here, which is asking me to assign it to a new station, essentially, which is I've got that bicycle assembly station. Now, if I have any other scanners at different stations, I'm essentially tying off that relationship that I mentioned before between what station am I working at, what device is performing that work. So when I go back into my torque action here and I assign a device, at that demo station, I have that QXX pistol, and at this bicycle assembly workstation, I'm going to assign that assembly right angle tool that I had just created. So this process can be done in parallel with different operators using different tools, and it's not going to be functioning in that exact same way to manage that workflow. So now when I've gone through and started configuring some of these devices and put some builds in the system, I have the ability to actually review my change control and traceability of these processes as I've built. So as I've gone through and done some builds, I can scan in that bicycle label that's printed out at that assembly step. When I enter that in within traceability, I can see my historical record of when these builds are done, start time, stop time, the operator that was working at that station, if there's any quality issues or notes that were raised during the process, and of course, any other scanned traceability items. So when I scanned in that seat post, I scanned in serial number 156W as part of that assembly, and I can manage that whole structure up and down the list. And of course, my main bicycle serial number is tracked over the course of that assembly through many different builds, and I can see those start times and stop times as needed. So I'm going to jump back into our presentation here to wrap up before we get to some final Q&A. So there's a few different places that folks get started with PICO on this digital journey. Of course, there's one of the initial digital work instructions of, I'm just starting. How do I get rolling? We have a free offering where you can essentially sign up, get started on your work instructions, and start managing your process flows accordingly. And then everything on top of that is layering on additional connected devices, error proofing to be able to support that digitalization journey. There's a couple different case studies here that are mentioned. One is, I have standardized work. I want to upgrade to see my full data traceability and analytics possible. We've got a great case study with Pollington Machine Tool that secured their tier 1 auto contract through Safe Launch as part of a requirement, be able to have 0 defects over their launch period. On top of that is our case study with Moride that integrated over 100 devices with PICO and has been building with 0 defects on an RV chassis driveline install, which is a really compelling story about when we've started integrating these tools. How can we actually start error proofing our process to be able to get to that next level of truly connecting all of those business systems? As I mentioned, the digital work instructions are free. So if you want to sign up at picomes.com, /try for free. You can evaluate which package is right for you. Of course, you can always start with basic. That is a free license in perpetuity. There's no week, month, 30-day expiry. You can use those and manage and get started on your journey as quickly as possible. From there, you can start saying, do I need that traceability? Can I start that error proofing with connected tools and start managing that? And that's on a per station, per user, or site license basis. There's no large contract required to start unlocking these powerful tools available for your factory. So as part of some next steps, please feel free to sign up for those digital work instructions and start upgrading those plans as I mentioned. We have all of our training resources available as well for quick onboarding and self-help as needed at picomes.com training-center. We have all of this content available, past webinars, recordings from yours truly to help you get started on your journey along with other folks from PICO. And of course, we're here to help along the way at help@picomes.com. So with that, we've got a few more minutes to jump back in for additional questions that came in and wrap up.
Great, thank you, Steve. We did have a couple more questions just pop in. Lindsay is asking, is there an option for the instructions to be stored locally in case of internet outages?
Great question. So there is an option as part of the essential package for the all of this that we kind of walked through today to be hosted locally. It's actually part of our standard offering to have a server on premise at the facility. It's a little form factor PC, functionally a black box server. But this actually is so that in case there is an outage, we're approaching fall. Actually, we are in fall now, and winter's just around the corner. So when storms start coming through, or there's any internet service provider outages, that server is living locally. So all those instructions, all those actions, all that communication lives behind your firewall on your network and doesn't require external connectivity. So that's a great methodology of getting away from some of the cloud options. Of course, cloud is always there for you as needed, but we primarily recommend living locally on your network for that reason, to have everything stored there for access. So you don't need an external communication to continue running your factory.
Okay, great, thank you. We have time for one or two more. Let's see, Mike is asking, how are tools connected to the hubs and how many can you connect to a single hub?
Yeah, each of the hubs can be connected to in a couple different ways. Each hub communicates via, there's 4 USB ports in each hub, so up to 4 USB devices. There's also 2 micro HDMI ports on the side as well, and those are useful for driving touchscreen monitors or other, work instruction display type interactions, either for touch interaction or purely just display to be able to interact with those things. So again, that's 4 USB ports and 2 HDMI outputs on each one. All of those hubs also have the ability to connect to your local network over Ethernet and Wi-Fi. So if you have that hub connected over Ethernet, you can if you have that hub connected over Wi-Fi, you can always have an Ethernet to USB adapter on that hub to get a little extra connectivity there. Outside of that, any tools or devices that are able to be connected on the Ethernet or on that local network that I just mentioned, and that's going to include your torque tool controllers, printers that have an Ethernet port. Same goes for high pot testers or any RS-232 to Ethernet type communication. There's an unlimited number of those. You're only limited by the number of IP addresses that you have available in the facility, which 9 times out of 10 is functionally none. So there's really no limit to the number of devices that you can connect via the local Ethernet or local network in the facility. And those hubs typically are anywhere between 6 to 8 different communication devices at each station. The easiest way to think about it, if you're going in a station setup with touchscreen monitors, is 1-to-1 for each interface, but anything else is going to be network driven.
Okay, thank you. Very good explanations there. I think we are just about up on time and we've answered the questions that have come in. So thanks everyone for joining us today. Just as a reminder, this has been recorded and it will be available on demand on our website. If you're watching this as a recording, please follow the links at the end of Steve's presentation if you're interested in more information. And we're always here to help you. So check us out at picomes.com. And thanks again for joining. And thank you, Steve.
Thanks all.
All right, bye-bye.